Hello, folks, and welcome back. Today we're going to be talking about our next set of topics for this unit, which is energy. So we've been discussing work and power. Now we're going to get into energy. So what exactly is energy? Well, energy is the ability to do work. Okay, so you can kind of think about work or energy as being kind of like stored energy or stored work. So let me restate that. You can basically think about energy as being stored work, right? Like you have the ability to do the work, and that's what energy is. You may not be doing the work at that exact moment, or you may be doing it. That's kind of the different kinds of energy that we have. Now, when energy is used, it causes changes. Okay, so whenever we use energy, it causes things to change. There are many different forms of energy, and we're going to be focusing on three: kinetic energy, gravitational potential energy, and thermal energy. So if we take a look here, right, we've got a kid pushing another kid in a car, right? There is energy being used here to do work. Remember, work is force times distance. So the boy, right, who's pushing the girl, right, he is using energy to make work happen. He has the ability to do work. We also have down here, we've got the thumb pushing onto the spring, right? So that is energy being used to do work. A force is being used to move an object a distance. So what is kinetic energy? Well, kinetic energy is the energy found in moving objects, okay? So any object that is moving has kinetic energy. So we've been talking about motion a lot this year, right? We've talked about how we can describe motion, speed, velocity, acceleration. We've talked about why do things move? Because a force is done on them. And we've talked about when things move because of a force, work is being done. So all of those things that we've talked about, they all have kinetic energy because they all have objects that are moving. Now, to calculate kinetic energy, we are going to use this equation. So we have got two equations for energy. The first one is kinetic energy. So Ke equals 1/2 mv squared. And our unit for energy is joules. Okay, so our unit for energy is joules. And that makes sense because remember, our unit for work was also joules. And because energy is the ability to do work, the units are the same. So then we have 1/2 times m. M stands for mass. Remember, our unit for mass is the kilogram. And then we have times velocity squared. And remember that our velocities are measured in meters per second. Now, one thing to note here is that we got to make sure that we use our math properly. I know that they don't necessarily maybe teach order of operations the same way for you all as they did when I was a kid. This squared part only applies to the velocity. Okay, so one thing one way that we can kind of think about that is that the velocity is squared. Okay, the squaring does not apply to the whole thing. The squaring only applies to the velocity. And if you do know order of operations, right, that's PEMDAS, right? Parentheses, then exponents. And the exponent needs to be taken care of first before you get to the m, which is multiplying all these together. So the first thing you always have to do whenever you're calculating these is to square the velocity first, all right? Okay, our next type of energy we're focusing on is gravitational potential energy, right? And for gravitational potential energy, that is the energy that is stored in the height of an object above the ground. And that's why it's called gravitational potential energy, because objects that are above the ground, right, have the potential to fall. So they have this stored energy that can do work, right? The object can move and maybe isn't moving at that time. So here we've got a person that is a real person that actually tight-roped between two skyscrapers, thousands of feet above the ground, right? So this would be definitely a lot of gravitational potential energy because if they fall, then they are definitely going to, be experiencing some acceleration. Some work is definitely going to be done on them. We also have cranes, right? Cranes are lifting things above the ground, right? And so this piece has a lot of gravitational potential energy because it is way above the ground. So because of that, right, gravitational potential energy is calculated using this equation. So GPE is equal to mgh. M is mass, which again is going to be measured in kilograms, and your height is meters, right? Because it's a distance. So basically what we're saying is that the higher you are above the ground, or the bigger the object you are, the more gravitational potential energy you have. Now the G, we've seen G before. G is the acceleration due to gravity, which is that 9.8 meters per second squared. Remember, we talked about this when we talked about gravity in our forces unit. G is a constant. G will always be the same. Okay, it's always going to be that 9.8 meters per second squared. And because GPE is energy, right, it's still going to be measured in joules. So kinetic energy and gravitational potential energy, they're both just different forms of energy, and so therefore they're both going to be measured in joules. So how can energy be converted, right? We have these two different forms of energy, the potential and the kinetic, so how can it be converted? Well, energy, and there are many types of energy, can all be converted back and forth to one another, all right? You don't necessarily, you're not stuck with one kind of energy. Energy is constantly being changed back and forth between the different types. When you bike up a hill, right, you have kinetic energy, you are moving, right? So if we think about a hill, right, as you bike up the hill, as you move up the hill, you are taking kinetic energy, the energy of motion, and turning it into potential energy. Because as you will go higher up the hill, right, your height is increasing. Okay, so you have more potential energy. As you start to move back down the hill, right, as you go down the hill on the other side, right, the potential energy that you've stored up from getting high above the ground, right, now you don't have to pedal. You can just go down the hill. Gravity is going to accelerate you, and the potential energy that you have is going to be converted back into kinetic energy. All right, so energy can constantly be converted back and forth between the different kinds. Kinetic energy can be used to make objects move up above the ground, right? That turns that energy into potential energy, and then that potential energy, when you want to use it or you release it, right, can be turned back into kinetic energy to cause objects to move. And we're going to do a virtual lab where we're going to take a look at that concept. So what is the law of conservation of energy? All right, this is our last big concept we're going to talk about. The law of conservation of energy states that energy is never created or destroyed. And you may remember the law of conservation of matter, which basically says the same thing, right? So the law of conservation of energy states that it can never be created nor destroyed. What this means is that the total amount of energy never changes. Now, just because the total amount of energy doesn't change doesn't mean that the kinds of energy change, or that the amount of each individual kind of energy doesn't change. So, for example, we know about friction, right? We know about friction, and friction is a force that makes energy conversions inefficient. So when we're converting from kinetic energy to potential energy as we go up the hill, right, not all of the kinetic energy that we have makes it into the potential energy. Some of that energy is lost as thermal energy, or basically heat. And so the same thing happens when you roll down a hill, right? As you go down the hill, you don't actually get all of the potential energy turning into kinetic energy. And so you slow down a little bit compared to what you maybe would. And we know this, right? If you roll a ball along the floor, it's not going to keep rolling indefinitely, because friction is going to be taking some of the kinetic energy that the ball has and is going to turn it into thermal energy. And thermal energy can't really be used for a lot. It can make us feel warm, right? It can heat things up, but it can't really do very much. It's not a very, what we would call an organized form of energy. We can't use it for a lot of things, all right? So in the video clip here, we've got Neil deGrasse Tyson, famous astrophysicist. He is releasing a pendulum, right, a ball from his nose. And so what's happening is that the potential energy that the ball has, because it's above the ground, is being converted into kinetic energy. It swings, and as it's moving, a little bit of that energy is being converted into thermal energy, right? And so it slows down the ball just a little bit, because again, that energy is being converted into a different kind of energy, into that thermal energy, and so therefore it doesn't come and smack him back in the face. It just boops him on the nose because of science. All right, folks. So make sure that you now go through and answer the summary of the notes. And then there are some practice questions where you're just going to be thinking about the concepts that we've been discussing here and applying them. So make sure that you complete that and submit it. Please let me know if you have questions or need help, and I will talk to you all soon.